Okay, calculus students, today we've got an important concept. It's a big picture item. It's a big ticket item that we have got to learn and really have mastery on, not just for today, tomorrow, but for the rest of the course. It really is. It's a big ticket item that we've got to drive home some concepts. So let's get right after it. Today we're going to be, you've had some experience getting a graph of f and generating a graph of f prime. Today, the reverse of that, you're going to be given a graph of f prime and utilizing clues from f prime to generate then a graph of f. So here's a graph of f prime. Notice this is what you're given this time. You're given a graph of f prime. So you always have to look at this. What am I given? Are they giving me f? Are they giving me f prime? Super serious, important, because your attack for arriving at the next graph differs greatly depending on what you're given first and foremost. So your directions in a problem like this will say use the traits of the red graph f prime to determine the traits of f. Then graph f. So we've got kind of 3 steps here organized so that you have an idea of how you should attack this problem. All right. The first one is to determine the useful intervals with the graph of f prime. So how do I determine useful intervals? Well, useful intervals are dictated by, in layman's terms, what we call peaks, valleys, and zeros. So as you look at this red graph, you probably can find some peaks, valleys, and zeros. Here, we've got some peaks, valleys, and zeros. At 3, we've got a peak. It also happens to be a 0. When x equals 1, we have a valley. And when x equals -2, we have a 0. Now I am emphasizing the x's here for the intervals. These are x intervals that you need to record. Okay? So I'm going to make a little chart here that records the x intervals. And this interval chart is a tool that you can use that will assist you in providing what the graph of f will look like when the dust clears. It's a very similar chart that you utilized when first given a graph of f and arriving at a graph of f prime. But let's take a look. Here's the intervals we're talking about. We want to go from -infinity to -2, and then from -2 to 1. The next interval is from 1 to 3. And finally, I see that arrow to the right of 3. We're going 3 to positive infinity. Those are the intervals. So that's the first step in arriving at a graph of f when given a graph of f prime. Determine the x intervals that are useful. Peaks, valleys, and zeros. Next. So I'm just rewriting what we have so far, these x intervals. There's the graph. And here comes step 2. We want to describe the traits of f prime on the chart. What are you talking about, the traits? The traits of f prime, like it's red? No, I'm really just talking about 2 things. Whether in each interval, whether f prime is positive or negative, I'm really asking the numbers associated, the outputs associated in each interval. Are they positive or negative? Or does the graph live above or below the x-axis? That's the only thing I'm talking about. So one attribute is in each interval is f prime positive or negative, and secondly, in each interval is f prime increasing or decreasing. Those 2 descriptions, those 2 traits will provide for us clues for specific traits of f. Okay? So I'm really just concerned with these 2 issues in each interval. Is f prime positive or negative in each interval? And is f prime increasing or decreasing in each interval? And we're going to have the f prime row down at the bottom, consistent with what you've had in your previous assignment. And let's look. You tell me, from -infinity to -2, first of all, is f prime positive or negative? I'm really asking myself, does it live above or below the x-axis? Living above the x-axis there from -infinity to -2, I know that the answer is going to be positive. And from left to right, I see that this graph is decreasing. So my two descriptions here, and I'll have this in each box, in this interval, f prime is positive. What do you mean it's positive? It's going downhill. No, I mean the outputs in each point in that interval are positive, right? I'm talking about the graph lives above the x-axis. It's positive there. And its behavior from left to right is decreasing. How about the next interval? From x values -2 to +1. Well, gosh, this looks entirely below the x-axis, so I know that the sign's going to be negative. And that's going downhill from left to right. It seems to be increasing. I'm betting the two symbols that I'm putting here are negative and decreasing. And you're Johnny on the money. Next, some students say this is where they fall off the boat. Take a look. I'm still below the x-axis. My outputs in this interval are still negative. So my first symbol is going to be negative, but I'm going uphill from left to right, so I'm going to be negative increasing. Check it. Negative increasing. And lastly, my outputs are still going to be negative for every point in this next interval. So my sign's going to be negative. And since I'm traveling downhill from left to right, I'm going to be decreasing. With experience, you will learn that there's negative decreasing. You're going to shift gears every time you go to a new interval. Something's going to change. Either the positive or negative sign is going to change, or the increasing, decreasing nature is going to change, or they both will change. You will find that you're going to shift gears on each interval. Those peaks, valleys, and zeros will dictate some kind of change, guaranteed. So that's kind of a nice check to make sure you're doing something, you're doing things right. You know, if you go to the next interval and you get identical, heads up, something's wrong. So now I've got nice descriptions for the characteristics, the traits of f prime. Let's see how we use these. So again, just reduplicating my chart here. Here are the attributes, the traits of f prime in our graph. Now for step 3, we want to use the traits of our red graph, f prime, and the traits we recorded on our interval chart to determine then the traits of f in each interval. So in each interval, I will know 2 things about f. So the 2 clues of f prime tell me 2 things about f. I'm going to give you this information, and then I'll have it formally on the last slide here that you can snap a photo of and have it for keepsies, because it's extremely important. But I'll share this with you, and you'll see the consistency. Wherever f prime is positive, f is going to be increasing. Let's think about that. F prime is a bunch of slopes. If the slope is positive, if the slope of a curve is positive, that means it's going uphill. The only way I can draw a positive slope is if the original function is going uphill, if it is increasing, okay? So that one should be intuitively, you should have an intuitive understanding of that. When f prime is positive, f is increasing, and when f prime is negative, then f is decreasing. That's serious important. Now the second description in each of these intervals, the decreasing or increasing nature of f prime will dictate the concave down or concave up nature of f. And without talking more about that, because we're going to get into concavity more specifically in the near future, I'm just going to let that rule ride and see if you guys can complete this interval chart along with me. All right, so let's take a look. So this first interval from -infinity to -2, since f prime is positive, I know that f is increasing. And because f prime is decreasing, f will be concave down. So the 2 clues in f prime provide for me 2 traits in f. In the next interval, f prime is negative. therefore f is decreasing. F prime is decreasing, therefore f is concave down. In the next interval, f prime is negative, therefore f is decreasing there. F prime is increasing, our rule then is f must be concave up. Lastly, f prime continues to be negative, therefore f is decreasing. And f prime's nature is decreasing, therefore f will be concave down. Now what happens with these problems, because everyone's sketch could be a little different, because everyone's like, well, I've got these nice traits, but where do I start? Oftentimes with these problems, when you're asked to graph f, they will provide for you a point. So what you see here on the top of the screen where it says f at -3 is 0, that's just an ordered pair, right? I want to plot the ordered pair -3, 0. It gives me a starting point or a location on my graph that f has to pass through. So when x equals -3, y equals 0, I place a little purple point there. Okay? And I've got some things highlighted on my interval chart. From -infinity to -2, my graph has got to be increasing. So all I'm going to do is put a second dot here that shows from left to right, from -infinity to -2, I'm going to be increasing. Now I need to connect those 2 points. Don't connect them with a straight line. You got to connect those 2 points with a curve that is concave down, with a bowl of soup that's upside down, with a small curve that looks like this. Concave down. Bam. That's what increasing concave down looks like. In my next interval from -2 to +1, my purple curve is going to be decreasing. So all I'm going to do here is find +1 and make sure that from the last point I plotted on the purple curve to my new point, which is somewhere on x equals 1, I have to make sure that point is lower than the last point I plotted. Why? Because the curve must be decreasing. All right, so I put it there. Now I need to connect it with the correct concavity. Is it concave up? Is it concave down? Is it a straight line? It's possible it's straight, by the way. You'll see them like this. This one's concave down. So that when I connect this, I've highlighted the abbreviation concave down. It should look like, so it should have some bend to it. Kind of an upside down bowl of soup. All right, let's go to the next interval. I'm looking at from 1 to 3. I got to be decreasing. So my next point's going to be below the last one I drew. Somewhere, right there. Somewhere below. Now, your point may have been further down, more drastically down than mine, or less significantly down than mine. Doesn't matter. Remember, we are sketching this curve. It doesn't have to be Johnny on the money. As class continues, we'll make a more specific graph. But all I have to make sure I'm doing from x equals 1 to x equals 3, I got to make sure I'm decreasing. And now how do I connect these 2 points? I need to connect these 2 points with a curve that is concave up. You're probably picturing this correctly, like that. All right? Lastly, from 3 to +infinity, I've got to be decreasing, so I'm going to plot a point that's slightly below. And I've got to be concave down, so I'm going to attach my curve with a small arc that is concave down. And I've got arrows on each end. Since my original curve's got arrows left and arrows right, my purple curve's got arrows left and arrows right. But this is the way the curve should look when the dust clears. Okay? Now, here are the conditionals that you guys want to see. These are the conditionals that provide for you what is it about f prime, then what can I conclude about f. These are conditionals. Do you remember this action? Conditionals from geometry. These if-then statements. Here they are. Number 1, if f prime is positive, if the red graph is positive, then f has got to be increasing. Likewise, if f prime is negative, then F is decreasing. Next, if F prime is increasing, and I know you're kind of getting repetitive words and so forth, you got to take some time, work on this, and sort it out. If F prime is increasing, that tells us something about F, that F will be concave up. If F prime is increasing, then F is concave up. And if F prime is decreasing, then I know something about F. F is concave down on that interval. Okay? That's the snapshot you ought to take perhaps here, kind of the nuts and bolts of what we've established. And so if you're given a graph of F prime, this is the information you use to determine in each interval the graph of F. And again, if they give you 1 point on F, you kind of have a good starting point to build from. Okay? So you've learned 2 new skills and you have to get them straight in your mind. Given a graph of F, how do you then determine a graph of F prime? And given a graph of F prime, how do you then determine a sketch graph of F and what it looks like? 2 important skills, and you can't go in guessing, you guys. You either know it or you don't know it. So spend some time, ask some questions, know it, learn it, love it, live it. You can do it, and you will. Some practice coming up. Good luck.